You know, if you step back and look at the modern knowledge worker's routine right now, it's entirely predictable. And honestly, it is a little exhausting.
Yeah, it really is.
You ask the AI a question, you wait, you read the answer, you find the flaw, you fix it, then you ask again, over and over.
Right, it's this constant, endless cycle.
Mhm.
You're basically acting as the world's most overqualified babysitter for a supercomputer.
That's exactly what it feels like. It's a treadmill. We are the ones providing all the power, right? We're the engine driving it.
Mm-hmm.
But I keep wondering, what if the tool could actually drive itself? What if we could just let go of the steering wheel?
Well, that is the exact question
Yeah.
changing the entire tech industry right now.
Mhm.
We are moving past the chatbot era and stepping into the era of the autonomous agent.
Welcome to the deep dive. Today, we are exploring a concept called the AI loop.
Yeah, this is a big one.
It's a fundamental shift in workflow where you hand over a complex goal just once. The AI then works autonomously in the background. It repeats its own internal process, checking its own work, until the result clears your incredibly strict criteria.
I am so genuinely excited for this one. We're going to break down the 5 specific steps of a functioning loop.
Mm-hmm.
We'll also examine the 3 hidden traps where everyone inevitably messes it up. And most importantly, we're going to show you how to build one today. You won't need to write a single line of code to do it.
Let's start with the core problem. The treadmill I mentioned earlier. Why are we so stuck in this ask, wait, read, fix pattern?
Well, it's mostly because we've been conditioned by the interfaces we use. I mean, we've been using these language models for a few years now,
Right.
and the routine feels highly productive. You type a prompt, it generates an answer, but then it just stops.
It always stops.
Yeah, exactly. You have to read what it wrote, parse it, and then decide what the next logical step is. You type another prompt to course correct.
Mm-hmm.
You are physically running every single step of the reasoning process yourself.
The moment you stop pushing, the work completely halts. You essentially become the bottleneck for your own productivity.
Yep, 100%.
The AI has all this potential, but it has no inherent agency. I like to think of the standard prompt like a vintage wind-up toy.
No, I like that.
It moves impressively for a bit, but then the spring unwinds and it just sits there on the floor. An AI loop, though, is much more like a self-driving car.
That is such a perfect way to look at it. With a self-driving car, you input the final destination exactly once.
Right.
The car itself navigates the turns, it analyzes the traffic, avoids the obstacles. It doesn't stop moving until you safely arrive at the address.
So how does the loop actually navigate those turns? The source material we're looking at outlines 5 specific steps to make this happen.
Right, so every true AI loop runs through this specific sequence. First is discover. Before it types a single word of the final output, it figures out what actually needs doing.
It takes a breath to understand the context.
Yes, and that context is crucial. Second is plan. It takes the big, overwhelming goal and breaks it down into actionable, sequential steps.
Mm-hmm.
Third is execute. This is the part we already know. The actual generation of the text or code.
Fourth is verify, I assume. It actively checks the work it just generated against the original goal.
You got it. And finally, iterate. If the work falls short during verification, it feeds the failing grade back into its own system.
Right.
It runs the entire cycle again. Discover, plan, execute, verify, iterate.
Okay, I want to push back gently on this structure for a second. Isn't execute really the only part that actually matters? I mean, that's where the tangible work is produced. The rest just sounds like administrative overhead.
It totally feels that way at first glance, but no.
Mhm.
Execute is actually the easiest part for an AI. The discover, plan, and verify steps are where the heavy lifting occurs.
Oh, really?
Yeah, that is where the actual cognitive reasoning happens.
Yeah.
If you skip those framing steps, you're just generating useless text at a much faster speed.
Ah, I see. That makes a lot of sense. It needs that cognitive framing to anchor the execution.
Right, and without that framing, the execution is completely blind. It's just guessing at what you want.
So, fundamentally, what is the main shift here for the user?
It changes your entire job description.
Yeah.
You are no longer micromanaging every keystroke or debugging every paragraph. You define the end state clearly.
And then you just let it run.
Then you step back. The work keeps moving forward without your constant input.
You stop pushing. The AI drives until it's actually done.
Precisely. It's a massive shift in leverage.
Now that we know what a self-driving AI loop looks like in theory, we have to talk about why they crash in reality. Because let's be honest, they do crash.
Oh, they crash constantly. It can be a beautiful disaster.
Which naturally brings us to the 3 traps of autonomy. the specific places where these loops inevitably break down.
Yeah, these three traps can turn a brilliant automation idea into a massive waste of your afternoon. The very first trap happens during that fourth step we talked about, the verify step.
This is where the AI checks its own work, right?
Well, that's actually the mistake. The most common error people make is letting the AI casually grade its own paper.
Uh-huh.
Language models have a built-in bias toward their own generation. They're designed to be helpful and agreeable.
So they just say yes.
Exactly. If you just ask it, hey, is this good?
Mm.
It will almost always say, yes, this looks great.
So if it's naturally a sycophant, what's the actual fix? How do we force it to be critical?
You need a real external check, something entirely outside the model's subjective opinion that automatically rejects bad output based on hard rules.
Okay, so if we're talking about generating code, for example, the external check would be a failing test script.
Right.
Or maybe a static analyzer. Basically, a tool that proofreads code for errors without actually running it.
Exactly. In less than 12 words, that is exactly what it is. It needs a rigid mathematical rule that simply will not pass unless the work is flawless.
Okay, so let's assume we've set up a strict external check so it can't cheat. Even with that, I imagine the system still loses track of what it's doing over multiple cycles. Is that the second failure point?
You hit the nail on the head. The second trap involves a concept called state. This is absolutely critical to understand.
Okay.
Every single time an AI model starts a new round in the loop, its working memory is wiped completely clean. By default, it starts fresh.
It has no idea what it just did 2 seconds ago.
None at all. It doesn't know what failed on the last attempt or what succeeded. It is completely stateless.
I picture it like stacking Lego blocks of data in the dark. If you don't save the blueprint of what you just built, you're starting from scratch every single time you reach for a new block.
That is exactly what happens. It just grabs random blocks again and hopes for the best.
So to fix this, we need to create that blueprint. We need state, meaning a saved file so the AI remembers what it just did.
Yes, exactly.
Why is establishing that state so crucial for the loop?
Because without that external record to read from, the AI is effectively an amnesiac.
Right.
It will try the exact same broken solution, fail the verification, wipe its memory, and try the exact same broken solution again. Endlessly.
Without a saved file, every single round starts from zero.
Yes. And it is deeply painful to watch your API credits drain while it does that.
Okay, we have external verification, we have state. What about the third trap?
The stop condition. Actually knowing when to finish the job and shut down. It sounds simple on paper, but it is notoriously difficult in practice.
How does it normally know when to stop?
Ideally, you give it a strict list of tasks. When the list is empty, it halts.
Right.
But in a loop, it rarely goes that smoothly. It gets distracted.
It drifts.
It drifts terribly. Look, I'll be honest, I still wrestle with Tromp drift myself.
Yeah.
Oh, absolutely.
Yeah.
You build a loop, you leave it alone for 10 minutes to get a coffee, you come back, and it has somehow decided to rewrite your entire project into a completely different programming language. Yeah, just because it thought it would be quote-unquote more efficient, it totally forgets the original parameters.
It gets completely lost in the weeds of its own logic.
Completely lost. And when that happens, a human has to step in, hit the kill switch, reset the task list, and pull it back to reality.
So to recap, to avoid the crashes, you need strict external verification, an external memory file for state, and a rock-solid, unbreakable stop condition.
Yes. And if you get those 3 guardrails right, the loop largely manages itself.
Beat. Which brings us to a quick word from our sponsors. Sponsor, mid-roll sponsor read. So, setting these specific guardrails for state and verification seems highly complex. It sounds like a lot of upfront work.
It definitely is.
Which forces us to ask the practical question. Is building an AI loop actually worth the effort for an average user?
That is the ultimate ROI test, return on investment. And the truth is, not every repetitive task needs a complex loop. In fact, most of them do not.
Sometimes a regular simple prompt is perfectly fine.
Exactly. Building a loop only makes logical sense if 4 specific conditions are true at the exact same time. If even one is missing, don't build a loop.
Let's walk through them.
Condition 1, the task repeats often. It needs to happen at least weekly.
Okay.
If you're building a loop for a project you only do once a month, the initial setup time completely ruins your ROI.
Makes sense. Condition 2.
Something can automatically reject bad output. We just talked about this with the traps. You need a failing test, a strict formatting rule, or a rigid checklist.
Right. If it can't be auto-rejected, it can't loop.
Precisely. Okay, condition 3. The AI can handle the entire job from start to finish, not just a piece of it.
Meaning no human intervention.
Yes. If a human has to jump in halfway through the process just to approve a draft or click a button, the loop is broken.
It completely loses its autonomy. It goes back to being a wind-up toy.
Right. And condition 4, the definition of done, must be entirely objective.
Wait, hold on. What if the task relies on good taste?
How do you mean?
Like, say, writing a really witty marketing email. Can't the loop just iterate until it's funny?
Well, it can absolutely write the email, but it cannot loop autonomously to perfect it.
Why not? I mean, it understands what a joke is.
It understands the structure of a joke, sure. But witty is entirely subjective. How does the automated verify step actually measure wit?
Ah, I see.
It can't. There's no mathematical threshold for humor. The loop breaks down because it doesn't know what objective standard it's supposed to meet.
So it just spins its wheels, constantly rewriting the same joke, or it just gives up and accepts a terrible pun.
Exactly. Subjectivity destroys the automated verification step. You need cold, hard metrics.
Right.
Did it include the specific tracking link? Yes or no? Is the word count exactly 500 words? Yes or no? Are there 0 grammatical errors?
So this requires a very specific, almost mechanical type of work.
Yes. Highly structured, highly repetitive, purely objective work.
Under what specific conditions is a loop completely useless?
Basically, whenever you need nuance, emotional resonance, or it's just a rare one-off project.
If the task needs human taste or doesn't repeat often.
That's it. Just save yourself the headache and stick to a normal prompt.
Beat. Okay, let's say a listener is sitting there right now and they have the perfect task in mind. It's entirely objective. It happens every single week.
Yep.
It can be automatically verified by a strict rule. How do they actually build this thing?
This is genuinely the best part of the whole concept. You don't need a computer science degree to do this.
You don't need to install any massive developer frameworks.
None at all. You can build a basic, functional, zero-code loop right inside a standard ChatGPT or Claude browser window. Today.
Okay, how does that actually work mechanically?
You basically have to pack 3 distinct things into one single massive prompt. First, you need a crystal clear goal.
Right.
Second, you need those strict success criteria we talked about. No soft passes allowed.
And the third thing?
A loop protocol. You literally instruct the model, in plain English, to repeat a sequence of steps every single turn.
What's the specific sequence we give it?
Plan, do, verify, decide.
Let's unpack the mechanics of that.
Sure. You're essentially giving it a micromanager checklist. You tell it, step 1, plan the next logical step. Step 2, do the actual work. Step 3, verify the result.
Okay.
And here is the real trick for making this work in a chat window. You explicitly tell the AI to aggressively score its own work on a scale of 1 to 10 for every single one of your success criteria.
You force it to look in the mirror, be brutally honest, and list exactly what is still weak.
Exactly. Because when it has to assign a number, it can't just politely say, looks good.
Right.
And that sets up step 4, which is decide. You give it a rigid rule. If every single criterion scores an 8 or higher, print the word final and stop.
And if it doesn't?
If anything is below an 8, print iterating and go back to step 1.
That's brilliant. You force it to fix its own weakest point first.
Yes. And the source material shares a fascinating real-world example of this exact technique. Someone ran this protocol to build a customer support email workflow using Claude.
Walk me through what happened.
Okay, so in the first round, the AI drafted a full comprehensive process. It laid out the trigger event, the drafting steps, the internal tools to use, everything. Then, per the loop protocol, it moved to the verify step to check its own work.
It scored itself out of 10.
It did.
Yeah.
And while doing that, it flagged a very specific, very dangerous weak spot.
What it?
It noticed that its own verification step for processing refunds only relied on a human manager briefly approving the draft email.
Okay.
There was absolutely nothing in the workflow checking if the refund amount itself was mathematically correct.
Wait, it caught its own structural logic mistake.
It literally printed the words, "That's a gate, not a check." It recognized that human clicking approve doesn't actually verify the data.
Whoa. Imagine it realizing its own logic flaw and fixing it instantly inside a single message. Too sex silent.
Yeah, it is genuinely incredible to witness.
Yeah.
Because on round 2, it didn't wait for the user to say, fix that.
It just did it.
It just fixed that exact weakness. It added a new automated step to cross-reference the order number with the refund amount, before the email ever reached a human manager.
And then it ran the verify step and scored itself again.
Exactly. And on this pass, every single criterion scored an 8 or higher. It met the threshold. So it printed the word final completely on its own, and it stopped.
And this entire multi-step process happened inside one continuous chat message.
Yes. The entire discover, plan, execute, verify, iterate cycle, packed into one master prompt.
In this chat version, how does it physically know when to stop?
It hits the mathematical threshold you forced it to calculate in the protocol block.
It prints final once all criteria score an 8.
That's the trigger. It forces the halt, solving the drift problem.
I have to say, that one prompt trick is practically magic. It makes autonomy completely accessible to anyone with a keyboard.
It really does.
But we do need to look at the practical reality of this setup. It can't be perfect.
Right. We have to talk about the ceiling.
Yes. Let's say I have this beautiful autonomous genius running my browser. What happens if I simply shut my laptop and go to lunch?
It dies. Immediately. The entire process evaporates.
That is a pretty hard limit for something we're calling autonomous.
It is the defining limitation of the manual version. This kind of zero-code loop only exists while you keep that specific chat tab active and open.
Because of the state issue we discussed earlier.
Exactly. Remember our talk about state. The browser tab is the state. The moment you close it, the memory is wiped.
And there is absolutely no external record of where it left off.
It's gone for good. You're back to zero.
It also means it can't act on its own timing, right?
Right. It cannot run on a schedule.
Yeah.
You cannot tell your browser window to wake up and check your support inbox every morning at 7 a.m.
And it can't dynamically react to triggers in the background.
Exactly. If a new high-priority lead comes in from your website, the chat window doesn't know. It can't wake up, process the lead, and send a custom email.
So it's essentially a brilliant set of training wheels. But at the end of the day, you are still the human turning the key in the ignition. You have to physically open the chat. You have to paste the master prompt. You have to hit enter. You are still the initiator. Real scalable automation, the kind that runs quietly in the background while you sleep, requires stepping out of the browser.
Right.
It requires heavier engineering tools, agent frameworks that handle state on dedicated external servers.
What is the ultimate fatal flaw of the manual loop?
It relies entirely on your active open browser session to even exist.
Closing the browser tab kills the entire process instantly.
Exactly. But honestly, for most people's daily repetitive tasks, that manual training wheel version is still a massive leap forward in leverage.
Really is. It changes the paradigm.
If we zoom out and look at the big idea here, the real shift isn't just that the underlying AI models are getting mathematically smarter. It's a fundamental shift in how you, the human, actually work.
You're completely changing your physical and mental posture toward the screen. Yes. You're going from pushing every single step yourself, leaning in, sweating the micro details, to stepping back.
Right.
You clearly define the goal, establish the guardrails, and then you just let the work finish itself.
I really want to challenge everyone listening to try this today. Start small. Take one simple, mildly annoying repeating task.
Yeah, definitely.
Maybe it's a weekly summary report you dread drafting, or a formatting email you constantly rewrite.
Just make sure it's something with a clear, objective bar to clear.
Put that loop protocol on it. Plan, do, verify, decide.
Yeah.
Experience what it actually feels like when the AI scores its own work, actively finds its own weak spot, and fixes it without you ever pointing it out.
I promise you, it is a profound moment when you see it happen on your own screen for the first time.
It really changes your perspective on what's possible, because if the heavy lifting of the near future is just stepping back, setting rules, and letting the loops run, well, it raises a deeply fascinating question. Are we moving from being the active creators of our own work to becoming the managers of our own personal artificial workforce?
That is a great question.
It's something for you to ponder next time you catch yourself staring at a blinking cursor, wondering what to type next.
Yes.
Thank you for joining us on this deep dive. We'll catch you on the next one.